Okay guys, so this is section 10.4. In 10.4 you learn how to add and subtract radicals, and you end up reviewing some multiplication with radicals also. So we're going to start off with the adding and subtracting portion of 10.4 and go over the rules for that. In order to add and subtract radicals, you have to have the same type of root and the same thing underneath each radical. So same type and same thing underneath. So in the example that I gave you, these are both square roots. We know that. So they're the same type, and there's an 11 underneath each of them. So that's why we're able to add and subtract these radicals. But when we do, you can only add and subtract the numbers in front, the coefficients. So this is basically 4 minus 8, which is negative 4. And I'll leave the radical 11 in my answer. Square root of 11 in my answer. Guys, to me, this was always a lot like combining like terms, because 4x minus 8x is negative 4x. And when you combine like terms, you just add or subtract the coefficients, right? The exponent on the x doesn't change. The x is still in the problem. So to me, this is a lot like combining like terms, if that helps you. Okay, so we're going to do a handful of these, because some of these are easy and some of them are difficult. So there's 6 examples we're going to do of just adding and subtracting. The first one is the square root of 27 minus the square root of 75. Well, they're the same type of radical, but there's not the same thing underneath. Since they're not the same underneath, then I need to actually break these numbers down and see if I can make them the same. Using factor trees. The only way I'm going to be able to move forward here is if I can simplify and get the same thing under those radicals. So I'm going to kind of draw an arrow over here. Square root of 27 minus square root of 75. Well, I know that 27 is 9 times 3. So if this is a square root, so I can take this pair out, but then this 3 will have to stay on the inside. 75, you can think of whatever gives you 75. I know I'm going to start with 3 times 25. 3/4 is 75. And then that's 5 times 5. So there's a 3 that stays in there, but I can take the 5 out. So now when I rewrite the problem, this actually becomes 3 radical 3 minus 5 radical 3. So after breaking the radical down, I actually can subtract these radicals. 3 minus 5 is negative 2, and radical 3 has to be with my answer. Okay? So now let's look at some other types of roots. So the next problem we're going to do is a cube root. So remember, in a cube root, we need groups of 3. So let's see, cube root of the cube root. Oh, I left something off. 2 in front of the cube root. So 2, then the cube root. Hope y'all can see that. Yeah. 2 cube root of 3a to the 4th. Minus 3a outside of a cube root of 81a underneath the root. So this is a little more complicated. Guys, 2 is already on the outside, so I'm not really worried about that. I'm worried about anything on the inside that I can do. I know I need groups of 3. Well, I can't do anything with this 1 3 by itself, but I do have 4 a's. So I can take an a out, and that will give me 2a on the outside, cube root of 3, and there's 1a left over, right? Just to draw that out for you. So we had a times a times a times a, so there's 3 a's that I can take out, and 1 left over. So that's where that a came from. Okay? Well, let's look at the next radical. Cube root of 81a. Well, a is going to be left there because there's not 3 a's. But I know that the cube root of 81, there might be something to that. You should have gotten pretty familiar with 81 by now to remember that it's 9 times 9 and 3 times 3 times 3 times 3. So I do have 3 3's that I can take out, and 1 3 has to stay in. Well, when this 3 comes out, I multiply it with whatever's there. Right? Because there's already a 3 there. So that's how I get my 9a cube root. This 3 stays in, and that a has to stay in. So we worked with this problem and simplified, and now we have what we need, the same type of root and the same thing underneath. So now I can do 2a minus 9a, which is negative 7a, onto the cube root of 3a. And as weird as that looks, that is your final answer. Okay? Alright, so I want to do one more of these, but I want to stick with one that has numbers and not variables. And in your notes, you'll probably see an extra example that I don't actually do with you, but it will be worked out for you. So it'll just be an extra example that you can use with these. But this one, the next one I do, is going to just have numbers in it. Okay? So I'm going to write it down here because I will have room. I'm just going to have to do some factor trees off here to the side to go with this problem. All right, so 3 radical, or square root, of 108 minus 2 square root of 18 minus 3 square root of 48. Okay? So I know I don't have perfect squares, so I know I'm going to have to do factor trees for all of these numbers. 108, 18, and 48. So that's what I'm going to do off to the side are my factor trees. So I'm going to make a little bubble over here so I can do these factor trees. 108. So 108, anything that gives me 108. That would, some of you are probably saying, let's see, 4 goes into 108, 2 goes into 108, 2 times 54 is 108. 108 divided by 4 is 27. So I'm going to use that one just because it makes my tree shorter. You can definitely start with 2 and 54 if you want. This is going to be 2 times 2, 3 times 9, and 3 times 3. So I can see a group of 2's and a group of 3's. This is all that's left by itself under the radical. So I know that the 2 can come out and this 3 can come out. Right? So if we know that 2 and a 3 can come out and 3 has to stay in, then I'm going to come down here and show you there's already a 3 that's there. Then I'm going to have another 3 that came out and a 2 that came out from my factor tree over here. And what stays in is a 3. This was the 3 that stayed in. So this is kind of what becomes this first term. So 3 times 3 times 2 is 18. Radical 3. So that's the biggest one. But I still need to work with 18. Well, I know 18 is 9 times 2. And I can get a pair of 3's from that. But the 2 has to stay on the inside. So I'm going to come over here. I already had a 2 there. Right? I already had a 2. But I can bring this 3. And I'll leave the other 2 on the inside. So this is going to be times 3. And the 2 stays on the inside. So that's going to give me minus 6 radical 2. One more, 48. Well, 48, 4 times 12 comes to mind. And that would be 2 and 2, and this would be 4 and 3, and 2 and 2. So I've got 2 groups of 2 and a 3. So I already have a 3 there. Times both 2's that come out, 2 times 2, and 3 had to stay on the inside. So that's going to be negative 12 square root of 3. Now, out of those 3 original radicals, only 2 of them have the same type and number underneath. So those are the only 2 that I can add. 18 minus 12 is 6. So 6 radical 3 minus 6 radical 2 is your final answer there. Sorry to go over my factor tree. Okay? So like I said, there's going to be an extra example included on what I post um, for you to look at. Okay, I want to go into a couple examples that have fractions next. These really aren't that hard. It's just that they can kind of throw you off by how they look. So let's say I have the square root of 3 over 2 plus 4 square root of 3 over 3. Well, I do have two radicals that are the same type and they have the same thing underneath. They have radical 3's in both terms, square root of 3's, but they don't, these are fractions, and we know that fractions have to have a common denominator. So in this case, I need to multiply to get that common denominator, which will be 6. But remember, whenever I multiply, this is a whole number. So this actually becomes 3 radical 3 over 6 plus 8 radical 3 over 6. You can only multiply regular numbers like whole numbers with whole numbers and radical numbers with radical numbers. So this is a regular 3, so I don't put it under the radical. But now I can go forward with this problem. It's definitely going to be over 6, same denominator. And then here I'm allowed to add these coefficients, 11 radical 3, because these are the same. So therefore I can add the coefficients. And that would be it. Now this problem you can't simplify. You can't touch that number under the radical, but 11 and 6 don't have anything in common, so they can't be simplified further. I want you to understand that you can simplify things as long as the numbers on the outside are the same. So let's say we had this problem. Radical 3 over 4 plus 9 radical 3 over 4. So I'm going to make this one easier for you because we already know how to get a common denominator. But I'm also going to kind of remind you about the invisible 1. Just like a variable, if there's nothing in front of a radical, it's understood to be a 1. So when I add these, it's actually going to give me 10 radical 3 over 4. Because I can add those coefficients. Same radical type and same thing underneath, right? Well, now I can simplify further because both of these are divisible by 2. So this answer is actually 5 radical 3 over 2. Okay?